Hi and welcome back. In this video, we're going to look at a couple example codes from what we covered in the last one. So I've created a new project in PyCharm. I've called it concurrency. And we're going to create a new file in here, a new Python file that I'm going to call threads. Okay, by the way, this code is available, linked at the start of the section, which is on the GitHub for this course. So let's say you've got some code that you want to run, like we saw earlier, that asks the user for something, and then some other code that does a complex calculation. Okay, we're going to have two functions. The ask user function. This is going to, get some input from the user. And then it's going to construct this greeting. And finally, it's just going to print it out, greet. This is what this function does. And as you know, this function here is going to wait for the user to type something. Okay? These functions here, or these statements here, are not going to wait for anything. We'd say that this is a blocking operation. Okay? An operation where your thread is blocked, waiting for something to happen. So these operations are what makes your threaded code slow. Okay? Don't worry about that too much. We're going to explore this concept more and more over the coming videos. Then you're also going to have a complex calculation function that is going to do something like print, started calculating, and then it's going to do something that takes a while. It's just going to do something pretty silly, x to the power of 2 for x in range 20 million. Okay, 20 million? 20 million will do. So this should take about 6 or 7 seconds in my machine. It could take longer or shorter in your machine, just tweak the number accordingly. Okay, so it's going to do that. And that's it. Then we're going to do ask user first. And then we're going to do our complex calculation. Now, of course, we're not going to know how long they take unless we start timing them. So we're going to import time at the top. And all I'm going to do is every function time it. So we're going to do start equals time.time. And at the end, we're going to print ask user time.time minus start. Okay. Same thing for the complex calculation. Now, I'm also going to do this for the whole program. So I'm going to track how long the whole program took. Like that. Okay. Again, all that's happening here is, first of all, we start a timer. Then we launch the ask user function, which starts a timer inside that function, asks the user for some input, waits for the user to type, constructs a new string and prints it out, and then it's going to print the end time. Then it's going to launch the complex calculation function, which is going to start a timer, print how you started calculating, go through this list comprehension, which is a pretty massive one. When it's done, it's going to print out that the complex calculation took a certain amount of time. And then at the very end, we're going to print that the single thread took some amount of time. You know from all the Python development we've been doing up to here that this is going to run from top to bottom. This is going to run first, and then this one, our execution is going to jump to here, then here, then here, then it's going to go back, and then it's going to go here, and so forth. This